Good morning, dear students. How are you all? I hope that you are all fine. Please take much care in this pandemic situation. So, dears, in our last classes, we have learned about force and balanced force, unbalanced force, and some etc. things. Today, we are continuing our discussion to the next level. So, before getting to start, let me ask you one question. Imagine that you are traveling in a bus at a certain speed. Suddenly, the bus has stopped. The driver has stopped the bus. What happened to you? It's very good. You will move forward. What is the reason? Okay, in another word, you are standing in a bus, the bus is at a stationary or is at a rest. Suddenly, the driver takes the bus. What happened to you? Yes, of course, you will move backward. So, what is the reason behind that? So, we are going to study all about these things. So, I am going to divide you into 4 different groups. So, group 1, group 2, group 3 and group 4. Let us consider another example. So, I have provided you some glass. Fill the glass with some water. Okay, about 3 by 4 times of the glass, fill it with water. Now, any one of you, just move that glass suddenly to one side. Move that glass suddenly to one side. It's very good. What happened? The water in that glass also moved. But in which direction the water moved? Yes, of course, in the opposite direction. You have moved that glass to the left side, but the water in that glass has moved into the right side. So, the glass moved in one direction, but the water in that glass moved in the opposite direction. This is nothing but inertia, or clearly inertia of rest, because the water was initially in that glass and the glass is at a rest, which means the water is also at a rest in that position. And what we have done? We have changed the position of the glass. We have changed the position of the glass, not the water. So, since we are lifting or moving that glass, the glass has to move, but the water inside the glass has a tendency to remain in its own position. So, we have a glass here and is filled with water. So, now their position is here. And now, what we are going to do? We are going to lift or move the glass to that side. So, if we are moving this glass to that side, the water in this glass has the tendency to remain here itself. It doesn't want to move to that side. So, that's why the water in this glass has moved in the opposite direction. That why it gets spilled out of it. So, all the objects has the tendency to remain in a state of rest. So, it alone can't change its state of rest. What happens in the case of that bus? You are standing in the bus and the bus is also at a rest. When suddenly the bus starts moving, the bus is moving, but you have to stand on your position itself. That's why you moved backward. So, we ourselves can't change our state of rest. This inability to not change the state of rest ourselves is known as inertia. Inertia means the inability of a body to change its state of rest. The inability of a body to change its state of rest. In the same way, the case of moving bus, we are in motion. We are in motion. So, when the bus suddenly stops, the bus has stopped but we wish to continue in our state of motion because we can't stop our motion ourselves. Without the help of an external force, we can't stop or change our motion. That's why we move forward, because until then we are moving in the forward direction. So when the bus stops, we won't take care of that, we again start to move in the forward direction. That's why we moved forward. So there we can't change or stop our motion, and that is known as inertia of motion. That is known as inertia of motion. So inertia of motion is the inability of a body to change its motion. To change its motion. So ourselves, without any external force, we can't change our motion, the direction, or we can't stop our motion. So this is inertia of motion. So hold together, both inertia of rest or the inertia of motion represents the inability of a body. The inability of a body to change its state of rest or to change its state of uniform motion. So let us watch a PowerPoint presentation regarding this. So dears, what is mean by inertia? Yes, inertia is the inability of a body to change its state of rest or change its state of uniform motion. So inertia is the inability of a body, to change its state of rest or state of uniform motion. So inertia is the inability of a body, of every body, to change its state of rest or change its state of uniform motion with itself. So without the help of an external force. If there is an external force, they can change their state of rest or state of uniform motion, that you are already known, already studied. So without any external force, they can't do it themselves. This is known as inertia. So let us find some more examples for inertia of rest and inertia of motion. So before finding more examples, let me show you another some observations from our classroom itself. You have to find whether it is inertia of rest or inertia of motion. Okay. So Arun, just off the fan. Okay dears, Arun has off the fan. So now look at the fan. What happens to it? Yes, it still rotates. The fan is still rotating. So why? Even the switch is off, the fan is still rotating. What may be the reason? Yes, of course, it is inertia of motion. It is nothing but inertia of motion. So the fan, even the switch is off, continues its uniform motion. That's why it took some more time to come to rest. So a fan, even after the switch is off, continues its motion. Continues its motion. So this is an example for inertia of motion. This is an example for inertia of motion. So let us consider another example. I have provided you another beaker. So fill that beaker with some water and place a cardboard on the top of that beaker, okay, or that glass. Now place a coin on that cardboard. Okay, have you placed it? Yes, very good. Now what you have to do is that suddenly remove that card. Okay, what happened? It's very good. The coin has put down on that glass. So initially the coin was on the top of that card and you have suddenly removed that card. So what happens to that coin? Very good. That coin has put down on that glass. So what is the reason? It's very good, yes, very good, because we have removed only that card. The coin has the tendency to remain in a state of rest or in that position. So that's why, since we have moved that card, the coin remained there as such, and that's why it has down on that glass. So what does it mean? Yes, the inertia of rest of that coin. So a coin on the card remains as such. So this is nothing but the inertia of rest. So this depicts the inertia of rest. In such a way, we can find more and more examples for inertia of motion and inertia of rest. So dears, I have provided you some activity cards. You have to write some more examples for inertia of rest and also inertia of motion. Is it clear? Okay. Okay dears, now let us watch a video about some more applications of this inertia. So observe it carefully. Okay dears, I hope that you have observed it carefully. See, in all those examples, what we have understood? Yes, of course, a body itself can't change its state of rest or state of uniform motion, and this is known as the Newton's first law of motion. This is known as Newton's first law of motion. Newton's first law of motion. So what is Newton's first law of motion means? all the objects in this universe, whether they are in rest or they are at rest or they are in uniform motion, whatever be the case, they themselves can't change their state of rest or their state of uniform motion until an external balanced force is acting on it. Until an external unbalanced force is acting on it. This is Newton's first law of motion. So what is this law means? A body at rest or in uniform motion, a body at rest or in uniform motion will continue in its state of rest or state of uniform motion. Will continue. A body at rest or in state of uniform motion will continue as such, will continue in state of rest itself, will continue in a state of uniform motion itself until an external unbalanced force acts on it. It continues in a state of rest or that state of uniform motion until an external unbalanced force acts on it. So whenever there is an unbalanced external force acts on that body, then that body will change its state of rest or that state of uniform motion, whatever may be the case. But until that external force acts on it, the body itself can't change its state of rest or state of uniform motion, and this is known as Newton's first law of motion. So I think now what happens to us in that bus, in any car, what happens to that coin when it is placed on that cart, what happens to that fan, everything are the examples for Newton's first law of motion. So don't forget this law, just write it down on your notebook and read with me. A body at rest, a body at rest or in uniform motion will continue in its state of rest, will continue in a state of rest or state of uniform motion until an external unbalanced force acts on it. So don't forget Newton's first law of motion. So dears, today we have discussed many things, many our real life experiences based on this topic. So inertia, today we have discussed about inertia. Inertia means, very good, the inability of a body. Inertia means the inability of a body to change its state of rest or to change its state of uniform motion. So that's what inertia means, and we have discussed why a person, a passenger stands on a bus, moves forward when the bus suddenly stops, moves backward when the bus suddenly starts moving. In the same way, we have discussed why a fan still continues its rotation even though the switch is off or even though the current has been offed. So these are all the examples for the inertia of rest or the inertia of motion of that respected objects. In the same way, as a continuation, we have arrived at the main theorem, the Newton's first law of motion, the best law of Newton, the Newton's first law of motion, which states that all the objects in this universe will continue in a state of rest or state of uniform motion until an external unbalanced force acts on it. So dears, study it very well, study it thoroughly. You have a follow-up activity. Find some more applications of Newton's first law of motion in our daily life. You have to find some more applications of Newton's first law of motion in our daily life and submit it tomorrow. So study well, take care, be cautious. Let us meet tomorrow. Until then, take much care. Thank you.